Okay, it's raining outside, so I figured I'd come out and shop and just mess around a little bit. And I was going to work on, I've got a high-speed spindle designed up, and I want to get the high-speed spindle done so that I can do my gaskets. And so I just thought I'd make a little quick video here of the way I was taught how to square up a block, because I've noticed some people on the web that have they don't understand how they're getting, why they're not getting their block square, and they're flipping it at 180 degrees and they're not loading the side they milled to the back jaw. And if you don't do that, you can end up with a parallelogram basically. So well, I'm going to attempt today to just show you the proper way to square up a raw block, and I got 2 blocks of aluminum laying on my mill here that I'm going to square up. And I'm going to use that for the collet clamp, or not a collet clamp, a clamp to go, a collar clamp to go around my quill on my NC mill, and that's where the high-speed spindle will be mounted. So anyway, here we go. So the first thing I've got 2 blocks here. They're pieces of extruded material, drop ends from other things. And the first thing I'm going to do, and this is just to show you that I'm going to start by loading those 2 sides against the solid jaw, because the solid jaw is perpendicular to the spindle. So I'm going to load this extruded side, since that's nice and straight and this is not so straight, and then I'm going to put that red back to the back of the jaw here, and it doesn't have to be real tight. I mean, it just you know, when you tighten your vise, just don't over tighten it. Yeah, I mean, if you over tighten a vise, you're putting too much stress here, and this back jaw, believe it or not, will move, and it will no longer be square to anything. And people that don't believe that, if you put an indicator back on the back side of the jaw and you put a block in there and you go ahead and tighten it up once, and you will see that it can move anywhere. I mean, it's not a big amount, depending on the vise too. This style of vise will move more than if you get in a precision NC vise where the sides are straight and you go in and clamp. It's more solid here, and those have the whole back side is bolted in, and those are a lot more solid. But these vices, if you tighten this up, depending on the vise, you can move this as much as 13 to 15 thousandths back here. So then you're kind of moving it, tilting her back. It's just something that, you know, a lot of people don't realize, and they'll hammer on their tightening, when they tighten it, they'll hammer to beat the band on it and tighten the crap out of it, and it's not necessary. It's you're doing damage to your vise actually by doing that. Okay, what I'm doing is I got a shell mill in there, a 3-flute shell mill, and I'm just going to come down and just touch the top of it, and I'm going to lock the quill in place, and I'm going to crank it off of the material, and I'm going to buzz across it. Plus, I always like to cut towards the solid jaw, not throwing the chips at yourself. You know, it's putting the pressure to the solid jaw. So I'm going to crank it up till it cleans up here. I'm going to go 20 style here and see what happens. That looks like that'll do her. A little bit of chatter here. I'll just do one block all the way through here. Okay, so that was that. So now I take that out, and this time I'm going to put the piece that I just, or the surface that I just milled, I'm going to put that to the back jaw. First I'm going to knock off the burr. Like that. Open this up. And I don't know if this parallel is tall enough. Oh yeah. And now notice I'm using just one parallel back against the solid jaw there. So when I lay that in there, it's just naturally going to flop down. And if you have material that's really out of square a bunch, what I do is I take a drill bit and I just stick it in front here and then tighten it on that, and basically that allows it to rock and clock up to the back jaw. But this block wasn't that far out of square so that I need that. So, but sometimes if you get a like this edge, if this edge was really angled or something, you'd want to do that. Okay, so again, don't over tighten, just basically just snug it up. Crank it down. And I'm just touching. And then I'm just going to take 10,000ths off. Okay, now if your head is out of square and you're running an end mill or a shell mill or a fly cutter, you'll end up with this line here, and this one here just I really can't even hardly feel it. But if it's a couple thou, you're going to have a couple thou or 3 or 4 thou mismatch there. Well, this here is not that. I mean, it's virtually nothing. I know that it's dialed in. I checked it just a couple days ago. And that's something else too. You want to check that every now and then. Make sure that you're square. If you bumped your spindle into something. And okay, so now we've had it here. We had it down. Now the edge that we just milled, we put that down to the bottom. Take the parallel out of there, put that in, and then just snug it. And here you can take a hammer and just give it just a couple light taps. That just makes sure that it's seated down against the. You don't have to hit it hard. You don't have to pound on it like you're pounding in a fence post. Okay, and you just touch again. Take it off. Go up 10 thou. On these blocks, I'm not really going to a dimension per se. Wherever they clean up is fine for what I'm going to use them for. Again, hit the edge. And now, it really doesn't matter which side you put to the back jaw, because now these two edges are perfectly square to the bottom. That is, if your head is, I mean, if your head wasn't square, naturally you'd have some mismatch. You'd notice it. So now that it's square, you can actually go with one. And I don't have the other parallel laying here, so, and it does not matter. You don't need both parallels. You just put the one parallel in. Put your block in there. Just lightly snug it. And then I put my thumb underneath and move the parallel back and forth and just tap on the back edge. See, one tap, I actually sat it in place. Move over. Touch. Move off. Crank the knee up 10. Okay, I quick give that a little deburr, and now all we have left are the ends. And for that, I just use an end mill. Just put it in here and stick it out on the side a little bit. Snug up your vise. Give it a tap, and now I get 3/4 inch end mill. Here's one I just sharpened. Yeah, this is one I just sharpened the other day, so hopefully it'll cut. Take that out. Put that in there. Bring it down. Turn my feed rate off on my power feed off, so I don't accidentally plow her in. Okay. My first pass will be a conventional cut across. So I'll go in and cut this. And I'll take about 25. That's pretty good. Now I'll find it. I'm taking 10,000s now. Okay, now that edge, I didn't quite clean up all the way, but close enough for me. But it's square and true to everything. So and basically you turn it around, do the other side to the length that you want, and it's done. So yeah, basically that's pretty much how you actually should square up blocks, because you'll end up with your blocks nice and square that way. You won't end up with, oh crap, this block is a parallelogram, it's not really square. And I've seen that happen even where I work. There are people out there that really don't know how to square up a block, so you have to kind of guide them that, no, that's not, because they think that, well, I got to mill these two sides parallel first. Well, that's not true. You want to mill two sides perpendicular to each other first. That's the first thing you got to do. That gives you a foundation for everything else that you do. If you start with a block that's not square, you don't have a good foundation. Your part is not gonna come out how you want it to come out. Anyway, I hope that's of use to somebody. Now I'm going to go ahead and continue my little project here. I'm still working on that project. I just thought that maybe some of you would like to see what they call a corn cob end mill, a roughing end mill in action. This is actually an end mill made for steel, because they make a 3-flute, which I don't know if I have a 3-fluter, but they remove metal without vibration, grabbing, and you can move a lot of metal real quick with them. And I just thought maybe I'd let you give you a shot at how they work and how well they work. I mean, if you want to remove metal fast, my camera shut off on me. I must have hit the button, but anyway, here, see if it'll zoom in on this. Focus. It's not wanting to focus, but you can see the edges in it. They're rippled. I mean, it doesn't have a straight flute, and they, like I say, they will remove metal really well. Now, being this is an if I had one that was meant for aluminum, I wouldn't even have to put coolant on it. But since this is one that's actually meant for steel, the clearances are not enough, and it rubs a little too much, so it gets warm. But it'll still remove metal like it'll remove metal like crazy. That's about a 700 thou cut. I mean, it's really good. It's basically a roughing end mill for, you know, roughing. I roughed a little over 700 thousandths off of that block in that amount of time, and that block is 1 inch. It's 1 inch thick, and by 700. I ran that end mill right across it, no problem. They are dandy end mills, so if you have a chance to pick one up at a cheap price, I would suggest that you do it, because if you do any material hogging instead of, you know, I could have went and bandsawed that off, but I don't know, call me lazy. I just grabbed an end mill and hacked it off. They're nice end mills. But I just wanted to show you that, you know, because I know that there's a lot of people that are on the board that have home shops that have never really worked in a shop and seen some of these tools. So, and I've worked in the machining trade for going on 42 years. So, you know, I've seen things come and go. But these have came and they have basically stayed, because they are, whoever invented them, they really cut nice. Anyway, thanks for watching. We'll catch you later.